everyone, this is Sir Tony. Our topic this morning is about random variables and probability distribution. Okay, so we have an example number 1. Suppose 3 cell phones are tested at random. We want to find out the number of defective cell phones that occur. Let D represent the defective cell phone and N represent the non-defective cell phone, and X be the random variable represent the number of defective cell phones. Okay, using the tree diagram, okay, this is the tree diagram. Okay, the first peak, the possible outcomes, there is a possibility that you can pick non-defective cell phone or you can pick defective cell phone. This is the result of your first pick. Then the second pick, the possible result, you can pick the non-defective, defective, non-defective, and defective. Then the third pick, there are also the result non-defective, defective, non-defective, defective, non-defective, none, and defective. So therefore, our first outcome N, N, N. So this is the first outcomes. Then the second outcomes N, N, D. Then the third N, D, N. The fourth N, D, D. The fifth D, N, N. The sixth D, N, D. The seventh D, D, N. And the eighth D, D, D. So therefore, we write this result in a sample space. This is the sample space. So these are so therefore we have 8 sample space. So we construct a table. So the first column, the possible outcomes. Okay, so this result, we can find this. Find this result in the sample space. And the second column, the value of the random variable X represent defective cell phones. Okay. So the first outcomes NNN, so non-defective. So meaning since we want to know the number of defective cell phones, so therefore the first result 0. That's why 0 because no defective cell phone. Then second result, we have 1 because we have 1 defective. The third result, 1 because 1 defective. The fourth result, 1 defective. The second result, 2 defective. The sixth, okay, so 2 defective. The seventh, 2 defective, and the 8th result is 3 because 3 defective cell phones. So therefore, the values are 0, 1, 2, 3. Okay. So we have example number 2. The balls are drawn in succession without replacement from urn containing 5 red balls and 6 blue balls. Let R represent red balls and B represent blue balls. Let Z be the random variable representing the number of blue balls. Find the possible values of the random variable Z. So using the tree diagram, we obtain a sample space. So R red, blue, blue, red, blue, blue. And the table, the possible outcomes, so this is it. And the second column, the value of the random variable Z represent blue balls. The first result, 0, because there is no blue balls. The second, 1, because we have 1 blue balls. Third result, 1 blue. And the fourth result, 2 because 2 blue balls. Therefore, the possible values of the random variable z are 0, 1, and 2. Okay, so let us proceed to how to construct the probability table, probability distribution table. So this result is the result of our example number 1, previous example. Okay, so this is the probability table. Okay, the first column, the values of the fictive cell phones represent x, 0, 1, 2, 3. So we have here 0, 1, 2, and 3. Then the probability, this is P is a probability of x. Okay, the first value of the defective cell phone is 0. Then that is the probability is 1 over 8 because by looking this table, only one zero in this column. So 1 0, that is why 1. And since we have 8 outcomes, that is why 1 over 8. Then the second value of the fictive cell phone is 1. So this 1, we have 3 ones, so that is why 3 over 8. Then the next values of the fictive cell phones is 2. So we have 3 twos. That is why 3 over 8. Then the last value of the fictive cell phone is 3, and we have only 1 3. That is why 1 over 8. In the probability, the sum of the probability is equals to 1. If this is not 1, meaning you have something wrong in the table. Okay, we have example number 2, and this is also an example of a previous problem. Okay, we have the first column, and this is the second column. The values of the random variable z represent blue balls. Okay, we construct a probability distribution table. In the first column, these are the values of the random variable z. Then this is the probability of z. So 0, and the probability of 0 is 1 over 4 because we have only one values in the random variable z, 1 0, the random variable z. That is why 1 over 4. In the second values, random variable z is 1. Then we have 2 ones, so that is why 2 over 4 or 1 half. Then next value is 2, and we have only 1 2. So that is 1 over 4. Then sum up, that is 1.